Welcome, folks, to weekly system design session. Today, we are going to do a mock interview, and we have Dan as a interviewer and Sreeprasd as a candidate. So the interview would go for 45 minutes to 50 minutes, up to these folks, how they want to run the show. So with this, I want to give the control to Dan and Sreeprasd.
Okay, thank you. So, Sreeprasd, are you going to share your screen?
Yeah, 1 second.
Okay, perfect. All right. So today I'm going to give you, a traditional system design question, which seems very simple at first, but I'm going to make it more difficult for you in terms of you are going to have to design a system that is going to grow by a factor of 10 every week into infinity. So basically the system is design a URL shortener that's going to grow every week tenfold.
So the main question is design a URL shortener service.
Yes.
Okay. And what is the one that you told? It's going to grow by tenfold.
Yes. So basically the workload, regardless whether it's a number of users or user activity, the workload on this service is going to grow by a factor of 10 every 7 days.
Okay. Can you give me a little bit more information about what you mean by a factor of 10? What do you mean by workload?
Okay.
So, yeah. Before we go, I just want to understand that this is a URL shortener service, which means user will be able to give a URL or send a URL, and he will get back a shortened tiny URL, for example.
Mm-hmm.
A short URL in return. This short URL, if a user hits it, will redirect the user to the long URL, the original URL.
Correct.
And that's it. I mean, it should not be like easily guessable or something, or it's not.
Yeah, so basically let's leave this aside because we want to make the system as simple as possible in terms of what it needs to do. There is one fine detail to worry about, which is whenever, let's say 2 days ago a person posted a long URL that was shortened to some kind of short hash. If today some other person comes with the same long URL, basically the result should be the same short hash that was generated 2 days ago.
Okay.
So okay, that's the only constraint that I can think of, but otherwise let's keep the requirements very simple. We don't need to do analytics. We don't need to do just make a simple system that's going to scale and scale and scale. And by let me explain to you what I mean by workload is growing tenfold every week. So basically, let's say you design such a system, and in the first week it has one user, generating 4 short URLs or 4 to 5 short URLs every day. Then 7 days later, you're going to have 10 people generating 4 to 5 shortened URLs every day. And then the week after that, there's 100 users, and so on into infinity.
So after
and I want,
yeah. Okay, go ahead. so there is a limit on the number of users. Like I'm assuming like there's a higher limit of say 1 billion users. Can I assume?
So let me explain. It's a very good question, but please do realize that a simple Python script can be a user. So if a person needs to generate, or a company needs to generate a lot of URLs, then they would launch, 10 or 20 scripts in parallel, and those scripts would each be sort of a user. So basically, I'm not going to constrain the problem to you in terms of users, because there are possibly 6 billion people that can use the system. The system can be also used by scripts and automated processes. So that's why I prefer to describe the things in terms of workload.
Okay. So you mean say bots can also be a user, and the bots can also generate or request URL to be shortened. And do I okay? So I need to store this URL also. So do I need to store it for X amount of years or something like that, or can I?
The URLs need to be stored forever. You cannot expire. No. Correct. Yeah.
Okay. Okay. So, okay, I think I have some information on the functional part. I cannot think of anything else at this point. I'm going to say for non-functional, I'm assuming the system has to be fault tolerant. Of course, it has to be highly available. Can I assume that or no?
Yes.
Okay.
It needs to be highly available.
Okay, it has to be highly available. It is a geo-specific, or can I assume that it is a geo-specific, like everything comes from a certain region, it has to be supported of that region?
It needs to work at planet scale. You cannot assume anything relating to geographies or anything. It has to work across continents.
Okay, and it has to be durable, which means if I send a URL to Shorten, and it has to be saved and it has to be retrieved, it has to be durable by that sense. Is that a fair assumption?
Yeah, correct.
Okay. What about latency? Can I assume that it is okay to be not like high latency, or is it like has to be very high?
So basically, you can assume that any person should either be able to shorten a URL or be redirected within 2 seconds.
Okay, within 2 seconds. Okay, that's okay. Okay, I don't know about latency. Let me come back to it after some time, and let me just do capacity planning. I cannot do capacity planning like you were saying, that if it's going to go every 10 days, it's going to grow. I guess my capacity planning depends on like the most simplest service I can think of is like just take some URL encoding, like for example 64-bit encoding, and if I take a long URL and make it as a base 64 encoding, like take a long URL, take it as a base 64 encoding with like 6 letters, that means I would get like around 64 raised to 6, which is around 70 billion, I think, 70 billion short URL. And I can start with that. Later on, if I want, I can change it so that it increases, or the other way around is I can start with like a 64-bit encoding with around 12, which gives me, I guess, the 70 raised to 70 kind of URL. So there is no limit on the shortened URL, right? Can I make it
correct? Yeah.
Okay.
I can give you an idea of the average size of the long URL, if you're interested in that.
Okay, please.
So that would be 500 bytes.
Okay, so a long URL can be 500 bytes, and okay, I need to estimate like how many how much storage is required for this 500 bytes URL, assuming that the load multiplies or doubles every 7 days.
Yeah, so you can think if you don't want to do capacity planning, overall, you can just do capacity planning per month or per year. That would be enough for me.
Okay. I mean, so I mean because it's like doubling every month. So per month, I will not be able to say because it's always doubling. So at least for 1 month, I can say that you need to store like around 500 bytes, and for every 7 days, you are giving me let's say 5 URL. So 4 times 5, like I'll get around 20 to let's say 50 URLs per month. This is for the first month, and then this will go increasing again after that. That will give you 500 into 50, that is around 2500 bytes, that is 2.5, at least in the first month, or even more. So can I assume that it's around like I want to say 250 or 2.5 megabytes in the first month, and then it goes on with the header and the short URL data and the additional overhead of calculating the hash and storing it. Can I assume that it's around 225 MB to 250 MB per month in the first month?
So yeah, let's see. Sorry. In the first month, you have you start with 1 user in the first week, and then you have 10 users in the second week, 100 in the third, and 1,000 in the fourth. So yeah, I think you can use that progression to make some estimation, right?
So around 1,000 users giving one user giving 5 URL, and you said 5 URL, right? One user.
Yeah.
And around 500 bytes per URL. This much will be my first 500 bytes per and 5 URL per user. This much will be my storage for the first. And I am like a little hesitant to calculate this. So 500 into 10 power 3 into 5, that is 25 into 10 power 6. That is 25. It could be wrong on this, but it's for me it's around 250 MB. Is that a fair answer?
Yeah.
That would be my initial storage, and I need to increase it per month. So I probably need to double it, or not. Yeah, not even double. It should be more than that.
Can I interrupt you for a second? So where do you have? So it's like 5 URLs per user per day, right? As far as one user is generating 4 or 5 short URLs per day, right?
Yeah.
So where is the where are you taking that into account when you go from 1 day to 1 month?
Oh, this is per day. I thought this was per month.
Yes, 5 URLs per day.
Okay, so yeah, I was assuming that this is per month. So it's 5 URLs per day. So then this multiply by 30 URLs per month, per user per month. So that's what 25, 3 to 7, 50. I'll round it about and say 1 GB per.
Yeah,
1 GB
sounds
per.
good. Yeah.
And if I have like 1 terabyte machine to store this, then I'll probably have like 1,000 machines 100 machines per for the first 12 months or something. Okay, that's around a high level I can think of. I'll probably use some database to store this, and that database should be a read heavy, because you write it once and then multiple users is going to read from it, and we probably need to store billions of records. That's a high level estimate I can give at this point. Do you want me to go further, or can I go to the next level of system design?
So let me interrupt you for a second here. And you said you have your storage requirement is going to be 1 gigabyte per month for the first month, right?
Yes.
But you're growing exponentially. So it seems to me like you are just extrapolating, linearly extrapolating from the first month to the entire year.
Okay.
So I just wanted to point that out. I'm not going to ask you to compute the storage requirement for 1 year, because that's not the point of this exercise. So yeah, at this point, I think you can move on to the next phase of the system design.
Okay, yeah, you are right. I was thinking about linearly, but this is going to be exponentially growing every month. So it's definitely going to cross limits even after 5 months, I believe. It's not going to be like 1 terabyte. It's going to be much more than that. And assuming that there are bots who is generating every 5 URL per day, then it's going to be exponential growing. Yeah, yeah. At a high level, that's what I can think of. Yeah. Do you want to?
Yeah, I'm okay with this, and if you feel free to advance to the next stage of the system design.
Okay. At a high level, so I'm just going to the next page. Let me know if you cannot see.
I can see your next page. Yes.
Okay. So let's go with the simple system that I can think of, and then I can think about scaling and durability and other highly availability and all. So what I can think of is like you have a simple user who's generating like 5 URL per day, for example. Right now you don't need a load balancer, but as the system grows, I'm thinking that you probably need some sort of a load balancer to balance the load on the service. So I'm just going to put a load balancer here. It could be round robin, or it could be based on user ID. So before that, do I need to worry about authentication and other services, or do I need to worry just about the backend for scaling the short URL service?
So yeah, the system is probably going to be based on some kind of API key, but you don't need to worry about that for now. Just design the simplest design, in terms of functionality, design the simplest system that you can think of. Just make sure it scales. Yeah.
Yeah, I mean, the simplest system I can think of is like you have a load balancer, which gives you, which redirects it to an probably an application server. So I'm going to say application server that invokes some sort of a service to generate a key based on the input that is given. In this case, I can think of is like a URL short service, which is basically taking your input and generating a short URL, and then passing it to this application server, and that application server is now going to store it onto the application server is going to store it onto a database. So what I'm thinking is something of a, so again a load balancer somewhere, so that it doesn't get a bunch of requests, and a database backed by a cache. So something like you insert it into a insert it into a DB, and you have a cache that is backing up this. So this is URL short DB or something, and this is now backed by a cache. So some sort of a key value pair, which gives you access. So this is a cache. So this load balancer might hit this cache. If it's not there, then it just inserts it into the DB. So I'm just going to add it one more. The cache gets updated by whenever it inserts, it also updates the cache, and the load balancer will get the value from the cache if it doesn't exist and then return it. This URL short service could be like a simple unique identifier generation service, which keeps on generating like some keys based on some DB. Like, for example, it can talk to some database to generate a list of unique keys, which the short service will be like relying on to get new IDs to generate, and then use that for shortening the URL and then returning it to the application server, which just puts into.
Can I interrupt you for a second?
Yeah.
Here I'm wondering, so the process of generating short hash, that's pure computation, right? That's not, that shouldn't go anywhere. You shouldn't use any other resources except the CPU for performing some kind of cryptographic function. I'm wondering why you are adding this additional database, and what purpose does it serve?
So this additional, when you say this additional database, is this the unique keygen that you're talking about?
Yeah. So I'm wondering how does that play a role, since the process of generating a new short hash, that's pure computation, right? That shouldn't have anything to do with retrieving something from a database or from some sort of permanent durable storage, right?
So the way I was thinking of is there is some central service which populates this keygen with certain numbers, and there will be replicas of this. So each short service will invoke one of these unique keygen. Every keygen will have its own set of range of numbers, and it will pull one of those numbers. And this will be happening only if the short URL is like a new one. If it's an old one, it needs to look at the load balancer, get the cache. If it's present, it's going to redirect. But if it's a completely new one, then it's going to like fetch it from the short URL service, identify the range, one of the keygen, get the range, convert it into a short URL, and that is the computation that you were mentioning, and then go and insert it into the DB. So I was thinking of having one pass up to this cache, and then fetch, if it's not there in the cache, fetch it from the URL short service. Even you can like compute and then go and see if it's in the cache. If it's in the cache, drop whatever you computed and then insert it into the DB. So you don't have to like make back and forth. That's one approach.
All right.
Yeah.
So so you mentioned two things here, and I'm curious about both. You mentioned some sort of external service. Can you draw the diagram for that? And then I have a follow-up question.
So this external service is what you're talking about is the keygen service is what I'm assuming.
Let's draw that. Yeah, let's draw that, and then now are you drawing a database, or are you drawing a service that generates the keys? I'm not sure exactly how you are planning to do this.
Okay, so initially I had planned of using a DB, but what I was actually going for is like some sort of a service which like unique like ID service. And this gets populated by some central central service which has all the keygen and unique ID gen service, and you just populate it a bunch of unique ID service with ranges of unique IDs that is generated from this keygen. This one will store it in some cache on its end, like Redis or some other cache. Its range of unique IDs, and if it's like if it's a request that is coming in, it will just get the new unique ID from this cache, convert it into send it back to the URL short service, convert the long URL into short URL, and then check if it's in the DB. If it's in the DB, it just puts it back into this cache, or it will insert it into the DB with the new short URL. That is what I had in mind. And this
okay. So you described a bunch of functionality. Let's draw all the arrows for that functionality, because it seems like you are passing data around, but your interconnecting arrows between your components do not reflect what you are describing. So let's draw all the arrows that for all interconnected components that pass data around, to each other.
Let me walk you through what happens if a user comes in. That will help you identify the interconnection services. So initially what I thought in my mind is, so there are two possibilities. One possibility is the user comes into the application server with a long URL. Long URL goes to the load balancer, checks if the long URLs present in the cache for a short URL. If it is present, then it returns and sends the short URL, or redirects the user to this short URL, to this, not redirects, it will create a short URL if it is not present, and then return it back to the user. Is that part okay?
So let's see. So you're basically talking, so there are two paths, right? There's the write path, which is the Shorten API, and then there's the read path, which is the redirect API. You're talking strictly only about the write path, right? Okay.
Yeah.
Makes sense. So makes sense for that code path. Keep going.
In the read path, the way I was thinking about is when the user hits the load balancer with a short URL, it goes to the application server, it goes to this load balancer, checks it if it's in the cache. If it's in the cache, it will return or redirect the user to the whatever is the equivalent of the short URL for the user. That's one read path, which is a happy path. Another read path is what happens if this cache doesn't have the short URL that the user sends. In which case, it will send an error to the user saying that this short URL is not present. That is the sad case where the user gave me a wrong URL, because our short URL service doesn't expire. So only if the cache doesn't have it, it will fetch it from the short URL DB. If it is not present in the short URL DB, it will say to the user that it does not have it, and it's a wrong URL that the user gave. But if it is present, then it's either present in the cache. If it is not present in the cache, it's going checking the short DB and get the long associated URL and redirect the user to the long URL. Does that make sense?
Yeah. So basically, you described two scenarios. There's one more scenario.
Okay.
One
more scenario for read, is it?
For write. So basically, you described one scenario for the Shorten API, where the the long URL has been shortened before, and it's basically about finding that short URL, returning it to the user.
Yes.
You have not described where the long URL has not been seen by the system yet.
Okay, so that is the write path. In the write path, a new URL comes into the system. So again, there are the way I was thinking about this. You pass it to the load balancer and check if the long URL is present in this cache. So this cache needs to now hold both the short and the long URL, both as key value pair. And check if the long URL is present in the cache associated with the short URL. Hold on one second. This is a URL shortening service. So you are giving me a long URL, and the long URLs API will be a create API, correct? Okay. So for a create API, it's going to check if this long URL is already present in the cache. If it is already present in the cache, it will just get the short URL associated and return that back to the user. If it's seen earlier, if it is not seen earlier, the application server will use this short service to create a short URL and insert it into the short DB, and that's it.
Okay, those three components on the bottom right, where you have a cache, a unique ID service, and the central service.
Yes.
I think I'm interested in more detail about them.
So the way I was thinking about is like you have a unique ID generation service which generates IDs like offline, like it will create a set of IDs and then keeps this unique ID service giving new IDs when it is expired. So for example, it will generate say 1 to 1000 and give it to service 1. Similarly, 5,000 to 10 to 6,000 to service 2, etc. So this is not one service; it's a cluster of services. So when the short URL service asks and connects, hits one of these unique ID service, it will get a unique ID for that that is present in that service from its cache, and then use it for calculating the computing the short URL. Once this unique ID service is like expired of this of its unique values, and that's why I'm keeping a small gap between ranges of IDs that was generated by the that is given to each of these services. For example, if the unique ID service one gets and please interrupt me if you're not following. I'm just telling you my thoughts, but please feel free to interrupt me. Unique ID service will give a range of IDs, for example, 1 to 1000. If it doesn't, if those 1000 expires, the next set that it gets is not from 1001 to 1010. It's probably getting somewhere between 2000 to 3000. So there is a gap, and there is in such a way that you never overlap. Another service will not get the same number that is given to one of these services. So there is no way that you can like overlap and get give two services the same ID. That's what I had in mind. Does that make
okay
sense?
This is where I think there's some technical debt in your design, but I don't think I think that we're going to leave that for the discussion afterwards. I would like to see your database design and what entities you're going to have in the database, and yeah, so let's do some database design.
So I had a simple database in my mind. Because it's going to be like read intensive, I'm planning to use some NoSQL database. That's what initially says. And here I had in my mind something like you need definitely you need the original URL, which is what the user gave, and this could be like a string, and do you need to know when this URL was generated?
No.
Okay,
no,
so
no,
I
just
need to know. Okay, because there is no expiration, I'm not going to keep an expiration also in this. Do you need to know who created this?
No.
Okay, you don't need to know that also. Okay, so then it's I don't know. So it's an ID. So this is URL DB, short URL DB, original, and maybe the hash or the hash or the short URL in this case. URL, which is again going to be a string. This string, I don't know, it depends on your 64. If you're using 64 bit for encoding, and you have like 10 or maybe 20 characters, then I mean 10 is much fine, I feel like, and that's why I'm thinking that it can be stored in a string. Does it make sense to you?
So here, let me interrupt you for a second. You have this table. So it has 3 fields, right? We know that the original URL, the long URL, that's going to be unique because we don't allow the same long URL to have two short URLs. We also know that the same relationship is true in reverse. So for one short URL, you're always going to have exactly one long URL. I'm wondering why you need that ID field at the top.
I'm usually familiar with a table with an ID field. I'm not like, in case you need to look for I mean, actually, if you can make this as the primary, and if these both fields are unique and non-null, and you can index on the short and the long URL combination both, then I don't think you need an ID. I'm just familiar with tables having an ID field, and that's why I put it.
Mm-hmm. Okay, all right. Is that the only table in your database?
If like the way I'm thinking about this is you need to go in both directions, and I was thinking of using a cache or something to put that in memory and then check if it's present. If it's not present, then use the DB to identify it, like whether it is a short URL or this short URL is present, or if the original long URL is present, and that's what this database is for. Last login user email, those are user details, which
we don't need those. Just so let's see. So you said at some point you said that you are going to use a NoSQL type database. Let's can you name one open source product? Cassandra. Okay, let's go with Cassandra. So in Cassandra, how would this table be indexed? I'm asking the question because the way you would build indexes is that you in a relational database, it makes sense to build indexes because it's in a relational database you don't need to read before. I mean, you do need to read before you write, but Cassandra is known for being able to scale specifically because you don't need to read before you write. And so the way that design is done in Cassandra is by access pattern and not by entity relationship. So can you describe to me how exactly are you do you plan to look up by short URL on the one hand and then look up by original long URL on the other hand?
So the way I was thinking of this, I'll probably use like this set of unique ID service to know the range, and I'll probably shard it by that range so that I know that if it's coming within this range, it's going to be in this sharded Cassandra part, and I'll redirect the user to that shard to determine whether the original URL or the short URL is present. And that's where I'm going to say that it is possible to scale. So you can have small amount of ranges and shard it according to that range and allow user to redirect to that particular shard based on the short URL or the long URL. But it will be a problem if you have a long URL that is coming in and you want to know whether this long URL is present or not. So I probably need to have another cache which stores this long URL. If it's not there, then I would require to go through the, but it's only like if I keep a fan out query to query these shards based on the original URL, maybe I can get away with finding out whether it is present or not if it is not present in the cache. But I'd still like to maintain it in the cache, and it's around 65 a billion URL that you're talking. That is if I have maybe 1,000 machines with 15 GB, maybe I can get away, but I'm not sure on that.
Okay, so I think we're running out of time. We're at the 48-minute mark. So I would ask Asim if if we can have some community discussion at this point.
Okay, so
I think the interview started at 9:10. If you guys want have another 5 minutes. I think
All
that's
right.
fine.
Okay.
One.
All right. So at this point, I would say, yeah. So if you choose Cassandra, then Cassandra does the sharding transparently, and it's not up to you how you shard. You basically define in Cassandra, you define something called a partitioning key, and then you define something else called the sort key, or it's called a clustering key in Cassandra. And together, these are going to make up the primary key for a table. And so I would be interested if you could describe what exactly is the partitioning key and what exactly is the clustering key if you want to go with this scenario.
Okay, I'm not familiar with how internally how it works. So if I were to do it, then probably I would have as the partition key the hashes of the hash range or the unique ID range, maybe that I can use for sharding. But that's yeah, and sorted by uh, date, so that I can get the most recent one, or the one which is most used, that URL for returning it to the user. But yeah, that's the main thing. I've not internally worked on Cassandra.
Okay. All right. So this was basically the most interesting part of the whole system design session, which is exactly how do you design the database? So the system design is about knowing your tools, and if in a system design interview you suggest something like a relational database, it means that that's only going to work for some kind of company intranet system where you have a maximum of 5,000 users, or otherwise you could suggest NoSQL, and like you suggested Cassandra. But if you are going to suggest NoSQL, then you have to know that tool. So that's basically the most important thing that I would say went wrong with this session. The other actually, there's one other thing. You had this good idea of generating the short keys offline and then feeding them into the unique ID service. However, if you're going to scale that, you're going to notice that you need something else in order to make that work at scale, and that something else is distributed message queue like Kafka. So ideally, I would have liked to see some kind of Kubernetes hosted service that consists of several instances, each one generating short hashes, and each one pushing those short hashes in a stream into Kafka. And then whenever the shortening API needs a new short hash, it would ask for the next available key from Kafka, and it would go from there. There's another discussion to be had here, which is interesting. What happens if the two different users try to come to the system with two different long URLs, and the system by mistake or by accident sends to both of those API instances the same short hash. So that's a kind of a race condition that I would have liked to see covered.
Okay, I mean, for the race condition scenario, what I was thinking is, you before you insert into the DB, you probably needs to put a lock and say, okay, I've seen, I have put it in some intermediate service which checks whether it is existing in the short DB before it inserts. So there could be a slight delay before it checks and inserts it correctly and discards it or recomputes a new short URL before it inserts. but that will make sure that a unique short URL is generated per long URL at the cost of a little bit more time in computing and making sure that the short URL doesn't exist. That would have been my goal. The other thing.
Okay.
Go ahead.
Yeah, so basically my objection to this, you mentioned at some point that you are going to use a lock, and that's a huge no-no in a distributed system that needs to scale. A system like this needs to be lock-free. You need to either find some sort of a two-phase commit solution to this, or you need to have some kind of optimistic locking solution to this, and even that is going to look bad. So yeah. Anyway, so I think I would like to hear feedback from other people who watched the session and have maybe have different ideas on what could have been done.
Okay. Thank you, Sreeprasd. Thank you, Dan. So the wonderful session. So we'll open the forum to everyone, and people can chime in. They can suggest their thoughts there.
So then a question from my side, like you were talking about something Kafka streaming thing that we need to put the URL in, and the Kafka stream will give us the key. What's the sorted next hash key, right? So I didn't get that part. Like, what was your query for that part?
So the reasoning for this is that you want that key generation to like Sreeprasd said, you want that key generation to happen offline. And so you need some kind of way to deliver those keys into the shortening API, and you could do this several different ways. But the most the most scalable way, in my opinion, would be to push to have this service push those short keys into Kafka, and then the shortening API would read those on demand as as if and as it needs them. And in Kafka you can have consumer groups, and basically if you have a service consisting of multiple instances, all of those instances would be part of the same consumer group, and they would each read from separate partitions. And this is a system that you can conceivably scale, without further restrictions.
Okay, yeah.
So
one more question.
Sorry, if you were going to use Kafka, can you have control over when the consumers consume from the topic? You would have to spin up those consumers and spin them down every time you need to consume from the topic, right? Because it is a high throughput sort of streaming platform.
So Kafka has durability, and if I'm not mistaken, the typical retention period for messages in Kafka is about 10 days. Basically, Kafka is a kind of a store and forward type of queue. It doesn't work like a message, RabbitMQ. There's producers pushing messages into Kafka. Those messages are stored for a period of 10 days, and then consumers can go in and request request a stream of keys on demand without having to depend on a synchronous type of without having to work synchronously with the producers. So the producers and consumers in Kafka are completely decoupled.
I understand the decoupling portion. I'm just wondering if it is possible to have the consumers choose when they want to read from the topic. Because for my understanding, you either sleep and otherwise the consumer's constantly reading from the topic. And I am aware that it offers retention periods. You can configure the memory, time limit, etc. But that wasn't something I was aware of. So
So yeah, basically a consumer will essentially at its own leisure request 10 or 100 or 1000 messages from Kafka. It will go about its business, and when it needs another batch, it will, Kafka will remember the offset where the consumer left off, and will give the consumer the next 1000 or so items in the queue. It's completely on demand.
Yeah, but if you use Kafka to keep already generated ID, yeah, you producer should always add some number of ID, yeah, and
Um, yeah,
when producer will know that new ID is needed.
okay, I understand the question. It's a very good question. Let me. Okay, I feel like this is an interview where I'm the candidate. Anyway, so let me answer that question. Basically, Kafka has an API where you can read the lag for every partition in a topic. So basically, you have a topic. You're pushing items into this topic, and then there's an API which if I'm not mistaken, is powered by JMX, which is going to give you the number of yet unread messages. So basically, this would run on the Shorten API end. The Shorten API would occasionally read, however many items are there in the queue in each partition that it has not yet processed or it has not yet requested. It's called lag in Kafka terms, and it can basically periodically store that somewhere, or for later review by the key generation service. So it is possible, yeah.
Thank you.
And then there is, I have an input, like just a question. So no doubt that Cassandra, like no in type of NoSQL databases, is fine for these cases. Like if we consider the scalability on the factor of 10, the data is growing in on the factor of 10 for every week. But I mean, can we have something like time series database also? If we have some metadata in the URL shorted URL itself, that basically timestamp as the metadata, and we can have that on the basis of that timestamp. We can simply have time series database on the basis of timestamp, and we can simply fetch from that also, making it hyper table and like that. So that will be helpful in the querying also. That I mean, so is that also a good idea to go with the time series database if we have timestamp as the metadata?
I think this is a good question for the interviewee. So Sreeprasd, could you answer that question?
Can you repeat that once more? I couldn't get that.
Yeah, sure. So it's like no doubt. I mean, the Cassandra, whatever the NoSQL database is good for in the factor of scaling. But can we have something like time series database also, in which we can have time stamp for every URL as the metadata, and we can store it there in the database. And on the basis of timestamp, we have the shortened URL, and we can basically, if and the requirement is something like if the same URL is going to be hashed again, so the same URL should be returned, right? So we have the same hash and key value pair for the same URL. So that can we have from, and that can be written from timestamp also. So that and we can make the hyper table for that time series database, which can help us to read also very fast. So is that a good point to go with?
The only fear I have is like how will you compute a unique time per server? Like one server and like multiple servers we are talking about, and while inserting we need to have some sort of a clock which is giving you a unique timestamp per unique long URL that is coming. If you are going to have multiple server and those servers individually compute the time on their server and then stamp it on the short URL as like a key, I fear it might be a chance that there will be collision. Two URLs having the same two services giving the same timestamp. If you can use it as part of the key maybe, but not the uniqueness guarantee for what we want. That's what I'm fearing if you're using timestamp.
Okay, but if we think something like we have a global service which can talk to every instance, and it can give timestamp, centralized timestamp for every services. So will that help us to basically.
But isn't that my global unique generation service doing the same thing? Like it is globally identifying a unique number, sharing it with the user. You isn't like what you said exactly the unique gen service also doing?
Yeah, correct. I mean, in the
maybe-
sense that we are using Cassandra here, so is it also good to use to go with that type of approach, like using time series database, having a global service which gives us timestamp for every instances?
If you're using time series database, how would you partition the if you are doing it based on the timestamp? Your partitions will be unequal size, right? Because the rate at which we are growing is 10 per week, right? So you cannot partition equally, right? That is one of the drawback I could see. And also the querying, right? So you need to query back the data. So at the time you need to query using the short URL. So, but for time series database, you need to know what time it got created. Then only you can do the querying, right? So I feel Cassandra will be a perfect fit for here, because if you use the short URL as the partitioning key, and the partitioning key will be growing, and the partition size will be equal, and based on the short URL you are going to look. So that is the partitioning key. So it will easy to redirect to the right partition, and you can query the long URL from the right partition, right? So that is what I feel like. Cassandra would be right fit, and the time series would be hard to query back, or partitioning based on the requirement.
What is the or motivation that you would see by using this time series versus another database, or like for example Cassandra or NoSQL or SQL or any other DB? What is that unique benefit that you would get by using a time series DB for this sort of a problem?
So I was thinking of like if we can have metadata for every request, like for every URL, we have a metadata as a timestamp, and on the basis of that, if we can have some different approach, like Cassandra is obviously the best approach for this, but I was just wondering that can it be also a good approach to go with that, to have metadata as a timestamp as a metadata, and we can use that for partitioning also and other things, what we're using for ID here.
So the way I'm thinking about this is it's like a unique number that you are representing your timestamp as. At that point, I could use a unique number generator also. Now, additionally, other than that, the timestamp would not give you any other benefit, according to me. Please correct, like if you have other thoughts.
Yeah, my suggestion is like if your input is growing in a constant phase, then probably you can use the time series database and partition based on the timestamp. But if it is increasing in this scale, then I don't think time series database can handle that.
Okay.
So basically, let me chime in here. So basically, in Cassandra, there's something called time UUID as the data type, and what time UUID is going to do is basically it's going to disambiguate timestamp, records which have the same timestamp, and it's going to make sure that the ordering of those records is completely consistent and predictable. You could conceivably be using a time UUID like this, but it would defeat the purpose of this being a shortening URL, because think about how long UUID is. It's pretty long, and it would basically you want either 6 or 7 or 8 characters in terms of how long the hash short hash should be.
Hi, I have a couple of questions. The first question is like, why do we need a cache in this central, like unique ID service, right? When right now, like we have a Kafka producer, which will keep producing the unique IDs, right? Why do we need a cache there?
So when I designed, there was no Kafka. I was just pulling it from the cache.
But even with the older design, like we are going to hit the URL shortening service only for the first time, right? When we need a new short ID. Like we are not going to keep fetching it every time, right?
So the way I was envisioning is the short service would call one of these unique ID service, which would have all the unique IDs stored in its cache, and it's just going to pull out from the cache and return it to the URL shortening service. And that's why I had a cache. In the design that is represented, like instead of this cache, the unique ID service would like, let me just delete it so that there is no confusion. It would just put it into the cache, and the URL shortening service will just pull it out of the cache every time it wants. So there will be multiple copies of this URL short service, which will put into the cache, into the Kafka, and multiple URL short service will be pulling out from the Kafka, and that's what the interviewer suggested. Does it make sense to you?
Yeah, sure. And my second question was about like the placement of the central Unix ID generator itself, right? I'm just thinking like, shouldn't we somehow interact with the short URL DB? Shouldn't they be like closer together? Because when we have them as two different places, there are possibilities that the centrally generated unique ID may have collisions, right? Like, and then it could come back and forth saying, okay, this is already present in the DB, right?
So
like when we,
sorry, go ahead.
Sorry, like when we get a new request for creating a short URL, like probably we could fetch it from the DB and then get the existing record and then try to increment it and then put it as a new URL or something.
So the way I was thinking about this, there is no like once the number is used, it's like gone, unless there is no it's only appending only. So there is no way, there shouldn't be a way that you are using the same URL, a short unique ID for generating the short URL that is being reused. For example, if you are using one number and you are inserting it into the short DB insertion failed, you need to pick up another number and then insert it. That was the way I was thinking about it. That's why I kept it as separate. The way I'm understanding what you're telling is we can maybe reuse or increment by one if it's already present. Then there is no unique ID service at all. We just fetch whatever is there. We just append to whatever is existing and add a +1 to the short, the unique ID. And that's not what I'm trying to do here. I'm just trying to say that,
okay,
yeah.
But there is a little bit of challenge, right? Like, so if the unique ID service has no awareness of the existing IDs that are created, then how will it guarantee uniqueness over a period of 10 years or infinity time, which was the ask? I think that is what.
Yeah.
So in my understanding, you have generating services which it generates in terms of ranges, and that range is what's storing into the short DB via the short URL DB via the unique ID service. So the unique generation service is going to keep on generating based on those ranges, and those ranges will never overlap. And that's why I'm telling like that it is not a requirement that the unique ID service know about the short DB. The only reason where I'm thinking that you would need to know is when you want to say, hey, I have like, I'm like reusing this, or for some reason I saw another one with the same number. So I'm going to ask for a new one or do a +1. And that is not the requirement. Can the interviewer chime in here?
Yeah, so let's see. I had there's a way to make this work, and it's basically by borrowing ideas from a few different places. It's basically leveraging this TimelyUID a data type in Cassandra on the one hand. It's borrowing a few ideas from the two-phase commit, and it's also borrowing a few ideas from optimistic locking. Basically, in the design that I had in mind, you would the Shorten API would get next short hash from Kafka. It will at that point probe the database, the Cassandra database that goes from short URL to long URL. Is this short URL already present in the database? If the answer is yes, it's simple. Grab a new short hash from Kafka and start the process all over again. If the short hash does not already exist in the system, then what it can do is it can place some kind of reservation, and there's a way to design an additional table for reservations, which would basically consist of the short hash of this short hash that we just got from Kafka, a time UUID, which basically looks like inserting the current timestamp, and then the long URL. And basically, once you insert that combination of data into the reservations table, you immediately go out and read that reservations table again, and make sure that you do a limit one, which means give me the first insert, which is going to be the winning insert. So basically, that's going to make sure that two people using the same short hash never win. So basically, read the reservation table with limit one. Make sure that you are the winning API instance. And if you are the winning instance, go back and probe again the short URL table. And if it's still not, the short hash is still not there, then you have the green light to insert that record. So basically, that's a way to do this process in a lock-free way, and that's the original design that I had in mind.
So could another idea be use the current timestamp along with the somehow embed that into the short URL? That way, infinitely you can keep growing and not worry too much about collision.
Well, see, the point is, the point of a shortening service is that the short hash should be short. So if you are going to embed the timestamp into the short hash, then it's going, you're going to make it at least 20 characters long, and that's not the point of a service like this. So you cannot, I think, for usability reasons, you cannot do this.
I see.
Hi, I have a question related to Kafka. So I understand we need some async mechanism for storing unique IDs that the service can use in future. But I have a question that why can't there be a database in place of Kafka to store that service? Like one factor that I can think of is the latency, but this is a question for interviewer. Were there any other factors you thought that like any other storage solution is not an option here?
Yeah, so basically, if you look at, if you just try to Google for Cassandra anti-patterns, you're going to see a lot of good advice that says don't use Cassandra or any other NoSQL database as a queue. So basically, I think the the nature of the design here is that you have something that needs to produce some data, and you have something that needs to read that same data off of the other end. And the logical data structure would be, if you think about Java, the logical data structure for that would be to use a queue. And if you think about distributed systems, the logical data structure and product would be Kafka. And because the answer to that question in, let's say, Java is not a hash map, then I think a key value store like Cassandra is not the solution.
Okay, so it could be any other like message queue solution. It could also be like SQS or RabbitMQ queue, right?
RabbitMQ, SQS, I think is a good choice if you have enough money to to pay for all of that traffic. Because I am not sure that SQS is very cheap on the Amazon side, but RabbitMQ has been shown. I mean, the RabbitMQ has not been designed to work at scale. It's not designed to first of all to have retention, and it's designed for lightweight inter-process messaging. And not for, so it's basically optimized for latency, but not for throughput. So I think RabbitMQ is the wrong choice here.
Okay, yeah, makes sense. Thanks for explaining that.
I actually have a follow-up question on the same question on why not Cassandra instead of Kafka? Because the way I was thinking, and other people also brought up this concern on if it is a duplicate. So I was thinking that if we store it in Cassandra rather than Kafka, the generated URL from the unique ID service, we can also have like a flag there that if it has been used, and whenever a new request comes in, we can only return what have not been served already. So that's gonna help with like having less traffic on our production DB, which is the short URL DB in the diagram here. And we don't have to like keep checking if we have already generated it, and everything will be like served from that Cassandra DB rather than uh, putting that load there. And that's gonna also, like, our uniqueness problem will be solved with a DB here.
So
Are
is
there
that
any
a question
thoughts?
for the interviewee, right?
I mean, it's like an open-ended question on like why only Kafka here when where unique ID service is generating and putting some data, and like on the same question that the other person was asking, like it's just a follow-up that a DB would be helpful to make sure that it's unique and we don't have to keep checking the production DB. So would replacing Kafka with a DB make sense in that case with that perspective?
So I think if I understand the question correctly, the equivalent scenario for pushing stuff into Kafka and then reading it off of the other end, basically the way that you phrased your question points to some kind of offset. And the question, as far as I understand it, is why use Kafka as the product that keeps track of offset? Why not use Cassandra? Because you can also use offset in Cassandra, and that's true. But that would mean that you would be forced to use a single partition in Cassandra. And using a single partition, let's say you have a Cassandra cluster of 100 Cassandra nodes, and if your replication factor is 3, you're basically only using 3 servers out of all of that cluster. So three out of 100 servers. And that's not the way to scale Cassandra. The way to scale Cassandra is to make sure that you do good database design in terms of how you choose the partitioning key, and within a partition how you choose the clustering key, which is it's going to give you the sort order. Not sure if I answered the question.
Yeah, I think You did. Thank you.
I had a question, like for the DB side, when you said like we need to look at both sides, whether the long URL is present or if the short URL is present. Can you? I'm not that much familiar, but can you explain a little bit more about how do you do that in Cassandra in terms of like sorted key, like you mentioned?
So is that that's a question for me, right?
Yes, please.
In Cassandra, so basically the design that I had in mind for this is that you'd have instead of having one Cassandra table, you'd have two of them. One which has the short hash as the primary / partition key, and then you would look that up. You would look up the long URL based on that, and the other one that has the long URL as the partitioning / primary key, and you would look up the short URL based on that. So neither of these tables would have a sorting key. The only table that would have a sorting key is that reservations table I just mentioned, which would have a sorting key consisting of that time UID. Not sure if I answered that question.
Yeah, partly. Like you mentioned that one Cassandra would be having the short URL as the partition key, and the other one would have the long URL. It would still have as values the short URL and long URL also, right? On the other side, like you would use partition key to identify whether it exists, or you would use once you find the partition key, get the short URL. If it's the partition key, is the long URL, get the short URL, or the vice versa.
Yeah, so basically it's like simple key value type of scenario, and you'd simply look up, probe each one of the tables for whether or not a record exists or doesn't exist. It's a simple yes or no question, and that's all there would be to both of these tables.
Got it. Yeah, thank you.
This could also be achieved with a global secondary index kind of concept in DynamoDB. Doesn't Cassandra have something similar?
Yes, Cassandra has secondary indexes, but it only has secondary indexes because enough large companies have asked for for that feature. You should only use secondary indexes in Cassandra in very specific situations, and it's you'd have to be really careful about the implication of this, because the secondary index is basically going to be an additional Cassandra table, and but that's not going to be under your control. Basically, it's more of a operations type of thing, where you want to design all of your tables in such a way that you have control over them. And if you define a secondary index on a Cassandra table, basically you sort of lose control over your operations, all of your Cassandra repairs and compactions and so on. That all of those are going to happen without much control from you. So yeah, basically look up Cassandra secondary index, and you're going to see some horror stories from people. But theoretically, you could use that. Yes.
Got it.
All right. I think we're nearing the 1.5 hour mark. So I think it's a good point at which to stop this interview. Asim, do you agree?
Yeah, I think interview is already stopped. This is only the discussion, and now if anybody has the feedback for the interviewer or interviewee, they can chime in. Or if not, then you can give your feedback to Sreeprasd.
Okay. So let's see. I'm not sure what kind of position you are aiming for, but basically whenever you do a system design interview, you need to be aware that the larger the company, the more they are going to be looking for this kind of scalable solution. And first you need to describe a trade-off between whether or not you come up with a relational database, SQL, traditional SQL database, or no SQL. And you need to know your tools, and knowing your tools means you're going to have to learn exactly what how Cassandra scales, and you're going to have to learn exactly how to do data modeling in Cassandra. And I have a good resource for you if you want to learn that. If you look on YouTube for DataStax 220, designing data models for Cassandra, I think you're going to find a YouTube playlist that's going to take you from ground zero all the way to expert in NoSQL data modeling. So if anything, I'm recommending to you, I'm recommending that you go through that entire YouTube playlist and learn the nature of the Cassandra beast, and then maybe do some research on the other kinds of NoSQL databases that exist, document databases, and graph, and so on. So yeah, if anything, I would give you this advice as a takeaway. You seem to be aware of how to conduct yourself as a candidate in the in a system design interview, and that's a plus. So let's see. You asked a lot of good clarifying questions. I would have so let's see. I would have liked to see a more detailed discussion about how you scale the APIs differently. Like you want to, if at some point the system becomes write heavy, you have the same kind of workload on the write side and the read side. I would like to know, see another discussion from you about how to scale those independently. Other than that, I think it was an interesting session, and it sparked a lot of community discussion. So I think we all learned about something about how to do system design at scale during this session, and I think it was a good experience.
Okay, thank you, Dan.
Thank you, Dan. That was really helpful. You mentioned to know the tools. I could have done a good job on that side for modeling Cassandra, but I'll definitely look up the playlist. Can you confirm it's on the chat that's the playlist that you are referring to?
Let me look. So okay, I'm gonna need to go to YouTube for a second with this link. Give me okay, let's see. Yes, this is the exact one I had in mind. Correct. Yeah.
Thank you. This was very useful for me too. Thank you so much for sharing your thoughts, and just everyone as well. Thank you.
All right. Thanks, everyone. All right. Bye.
Thanks, Dan.
Thank you, guys. Bye-bye.
Okay, I will stop the recording if there is nothing else to discuss, and then we can disperse.
So when are we having the next?